Hello, in this video, we will present the graph class. We will design the graph class, and then we're going to use it and implement it. The graph class defines the common operations for a graph. So this is the UML diagram for the graph class. Internally, we use a vector to store the vertices. So this V is a generic type. We use vector of vectors of edges to represent all the edges. So we use the adjacency list and using vector here. And this is the neighbors. This is the vector. So for each element in this vector, this is the neighbors brackets I stores all edges adjacent to vertex with index I. Noah constructor construct an empty graph. So this is to construct a graph with the specified vertices in a vector and edges in a two-dimensional array. This is to construct a graph whose vertices are the indices from 0 to n-1, and edges are specified in a two-dimensional array. Let's construct a graph with the vertices in a vector and edges in a vector of edge objects. This is to construct a graph whose vertices are the numbers 1, 0, and n-1, and edges in a vector of edge objects. Get size returns the number of vertices in the graph. Get degree, V returns the degree of a specified vertex. This get vertex with the index returns the vertex for the specified vertex index. Get index for the vertex returns the index for the specified vertex. Get vertices returns the vertices in the graph in a vector. Get neighbors returns the neighbors of vertex with index V. Print the edges of the graph to the console. This is to print the adjacent matrix of the graph to the console. This clear is to remove all the vertices and edges from the graph. At vertex returns true if V is added to the vertex, returns false if V is already in the graph. Add one edge, UV. Add, this is to create a edge. This protected function is called by add edge to create an edge using the edge object. Depth first search starting from the vertex V, and breadth first search starting from the vertex V, and the return is a breadth first search tree. So suppose we have the graph class already implemented. So we're going to write a test program using it. So this is the test program. So we have this, the graph .h included and h.h included. So this are the vertices. We use the figure for the map with US edges, US cities, and the edges connecting the cities. So these are the edges here. The number of edges is 46. So here we have this is the creating the vertex of the vector of vertices. So this is all the vertices, 12 vertices. And now copy from this vertices here and this to this vertex of vertices. So copy it from the array to the vector. So this is vector. And now creating the graph one. So the graph one is using this vertices. Here is vector of vertices. And with the edges. So this is the edges here, and the number of edges right here. This is 46. The number of vertices in the graph is graph one that gets size. The vertex with index I, so this is graph one that get vertex one. The index of Miami, so this is graph one that get index Miami. And this is to print all the edges, and this is to print the adjacent matrix. And here is another graph. So this is to use the functions and to obtain the property of the graph. So let's rewrite everything here. So let's do this now. I'm going to creating an empty graph. So let's do this now. So here is graph. Let's use this as the as this is string here, the vertex. So I'm going to create in this graph. This is the graph, creating an empty graph. So now I'm going to use this at vertex. So here is to add a vertex. So I'm going to add the vertex. Add the vertex is Atlanta. So let's add Savannah at Mecca. All right, so let's just compile and run and see if this can work, okay? So compile and run, so that is incorrect on at. So the function is at vertex instead. So let's go change that, at vertex, at vertex, at vertex. All right, so let's recompile. All right, so this compiled. So now let's add some edges. So graph dot add. So how do you do that? Add edge. So this is the one. So you add the edge using the index. Okay, so get add edge. So I'm gonna add edge. So the between Atlanta and Macon, so that is the index is, we're gonna obtain that index, graph dot get index for Atlanta. So then this is Mecca. And this is undirected, so we're going to have this Macon to Atlanta as well. And then let's have the edges for the Macon, Savannah. So here is Savannah, Macon, and then this is Macon, Savannah. So here is Macon, Savannah. All right, after this, let's print the edges. So graph dot And what is this print edge here is print edges. So let's invoke this print edges. All right, so let's run this program now. Is compile, run, and we're gonna see this is, so here's the result. And you have this vertex at this index 0, and this is the edge here, Atlanta Meccan, and for this Savannah, there's Savannah Meccan, there's edge, and for this Meccan, there's edge to Atlanta and edge to Savannah. All right, so this is now the implementation of the graph class. So please study the implementation. Its complete implementation is given here. That is all for this video on the graph class. See you on the next video.